Welcome to another episode of Terry's Notes, and today we're going to be looking at some coordinate geometry examples. If you have not looked at the coordinate geometry video, you should look at that first before looking at this one, okay? Because we're just focusing on some examples in this video. Okay, so this is from the June 2011 paper. So we have a diagram that shows a line segment which passes through the points A and B. So we have A and we have B. And the first part asks to determine the coordinates of A and B. So all you need to do is to read off the coordinates of A. So A is really minus 2, 3. And B is 4, 6. Right? So so all you have to do is to read off the coordinates directly from the graph. Right? So the point A is directly above the point x equal minus 2, and it's directly to the right of the point y equal 3. So that's how I got minus 2, 3. Right? So all you're doing, you just drop in a line here. That's how I got minus 2. And drop a line here, that's how we got minus 3. In the case of B, if we come down this way, we get 4 and we get 6 on this side. Right? So that is the coordinates of A and B. Then you have to determine the gradient of the line segment AB. Now you need to label what x1 is, y1, x2, y2. So the gradient of a line is equal to, give me 1 sec. Sorry about that. Okay, so so the gradient is equal to y2 minus y1 over x2 minus x1, right? And y2 is 6, so it'll be 6 minus 3 over x2 minus x1, which is 4 minus 2, which would be 6 minus 3 is 3, and 4 minus 2 is 4 plus 2, which is 6, and therefore the gradient is a half. Alright, and now they want the equation of the line which passes through AB. Okay, now we know that the general form of the equation of a straight line is y equal mx plus c. We have already worked out what m is. M is a half, so it's y equal a half x plus c, and we need to find c. So we can use any of the points A or B to find C. So I'm going to use B, which is 4, 6, and therefore we have x equal 4 and y equal 6. That's directly from the coordinates of B. So therefore we can write 6 is equal to a half multiplied by 4 plus C. So therefore 6 is equal to 2 plus C. Therefore C is equal to 6 minus 2. Therefore C is equal to 4. Right? So therefore the equation of the line becomes y equal a half x plus 4. Right? Now notice how I found C, but you can also find C by just reading it off from your graph, because C is a y-intercept. So where does this line cut the y-axis? You can see that it cuts the y-axis at the point 0, 4. So therefore I could have just read this directly from the graph, right? Let's look at another example. This one is June 2008, and again we have a straight line AB, and let's see what is happening here. Right, so the equation of the line above is y equal mx plus c. State the value of c. So the value of c is really the y-intercept. So we need to look at the graph to see where's the y-intercept. First thing we have to do is to make sure we know what the scale is on the graph. So this is the 0.5. So therefore this has to be 1, 2, 3, 4. That's 5. That's 6. This has to be 7. Let's make sure I label on this side as well. So this is 1, 2, 3, 4. This will be 1. This is 2. This is 3. And this is 4. Because if this is 5. So therefore the value of C is 7. So C is equal to 7. That is read directly from the graph. Determine the value of M. So M we know is a gradient. So therefore M is equal to y2 minus y1 over x2 minus x1. Right? So we need to use 2 points. We can use the points A and B. So from the graph we can see that A is equal to 0, 7, and B is equal to 2, 0. Right? So we can label A as x1, y1, and B as x2, y2. So therefore, if we substitute into the formula for gradient, it will be 0 minus 7 over 2 minus 0, which will be minus 7 over 2. So the gradient is minus 7 over 2. So M is minus 7 over 2. Next part is determine the coordinates of the midpoint of the line segment AB. So we know that midpoint, big M, is x1 plus x2 over 2, y1 plus y2 over 2. So this will be 0 plus 2 over 2 and 7 plus 0 over 2, and this will be 2 over 2, and this is 7 over 2. So M is 1, 7 over 2. Right? So that is the midpoint. The coordinates of the midpoint of the line segment AB. Right? So now we are on part B now. Let's set the point minus 2k lies on the line. Determine the value of k. So minus 2k, this is minus 1, this is minus 2. So therefore that point lies somewhere up here, which we cannot read off from the graph. So in order to find the value of k, we need to know what the equation of the straight line is. So we know what the equation of the straight line is. They told us it's y equal mx plus c. But we worked out what m was. So y is equal to minus 7 over 2x. And we know what's, did we work out c? Yes, we have c. Plus 7. So in order to find the value of k here, we just need to substitute x equal minus 2 into that equation. So when x equal minus 2, y is equal to minus 7 over 2 multiplied by minus 2 plus 7. Right? And so minus 7 over 2 multiplied by minus 2, that gives me 2 will cancel, so that'll be 7 plus 7, which is equal to 14. So therefore k is equal to 14. Right? Now they also want in part C to determine the coordinates of the point of intersection of the line y equal x minus 2 and the line shown above. So essentially we are solving a simultaneous equation where we have one equation being x minus 2, and we have another equation which is the equation of the line that we have. So let's call that 1, and let's call this 2. In order to solve for the point of intersection, we need to substitute one into the other. So you can substitute equation 2 into 1, and let's see. So this will be x minus 2 is equal to minus 7 over 2x plus 7. Right, so I've substituted y equal x minus 2 into, just to show you what I'm doing, I'm substituting this into this equation here, which is our original equation. So we can multiply throughout by 2, so we end up with 2x minus 4 equal to minus 7x plus 14. Carry all the x's on one side, we end up with 9x equal 14 plus 4 is 18. Therefore, x is equal to 18 over 9, which is equal to 2. And since we know what x is now, y is equal to x minus 2, which is 2 minus 2, which is 0. So therefore, the coordinates of the point of intersection will be 2, 0. Okay? This is a June 2007 paper. You have to determine the equation of a line which is parallel to this line and passes through this point. So remember, we're talking about two lines. So we have one line which is y equal 2x plus 3. And what they're asking us is to find the equation of another line which passes through the point 4, 7, but is parallel to that line. So it's going to look something like this. Okay, so we have y equal 2x plus 3, and this is the one that we want to find. So the first thing we need to know, when we have parallel lines, the gradients are the same. So from the first equation, they give us y equal 2x plus 3. Therefore, the gradient is equal to 2. Therefore, the gradient of the line that we want to find out is also equal to 2. So we know that m should be equal to 2 for that line. So therefore, y is equal to 2x plus c. Now they give us a coordinate, so we could use the coordinate to find the value of c. So we know that when x equals 4, y is equal to 7. And if we substitute that into our formula, we get 7 is equal to 2 by 4 plus c. Therefore, 7 is equal to 4 to is 8 plus c. 7 minus 8 is equal to c. 7 minus 8 is minus 1 is equal to c. Therefore, the required equation is y is equal to 2x minus 1. Okay, so just remember the rules for parallel lines. Parallel lines have the same gradient. We have another one here from June 2005. So we have a straight line that passes through the point minus 3, 5, and it has a gradient of 2/3. Write down the equation of this line in the form y equal mx plus c. Okay, so they have given us m is 2/3. They've also indicated that it passes through the point minus 3, 5. So therefore, the equation should be y equal mx plus c is the general form. So we know that m is 2/3, so it'll be 2 over 3 plus c. So we need to find c. To find c, we need to plug in, say, when x equal minus 3, y is equal to 5. And therefore, 5 is equal to 2 over 3x, but x is minus 3. So this is minus 3 here, plus c. So 5 is equal to minus 2 plus c. Therefore, 5 plus 2 is equal to c. Therefore, c is equal to 7. So therefore, the equation of the line we want is y equal to 2 over 3x plus 7. Now, we also have to show that this line that we just worked out here is parallel to this line. So how do we do that? We need to show that both of them have the same gradient for them to be parallel. So let's rearrange this one first. So we have 2x minus 3y is equal to 0. And therefore, minus 3y is equal to minus 2x. Therefore, y is equal to minus 2x over minus 3 and therefore y is equal to 2x over 3. So the gradient of this line is 2/3, and the gradient of the line we just worked out is also 2/3. Alright, and therefore we say that the two lines are parallel. We have another question here. I'm not sure which paper it's from. So we have a line segment GH, and we have an equation for this line segment. They want the gradient. So we have 3x plus 2y is equal to 15. We need to make y the subject of the formula. So 2y is equal to 15 minus 3x. Divide everything by 2. So this is 15 over 2 minus 3 over 2x. So the gradient m is equal to minus 3 over 2. Now they come in and tell you that another line segment GK is perpendicular to GH and passes through the point 4, 1. Determine the equation of GK. So visually we have GH, and we know the gradient of this line GH. So the gradient of this is minus 3 over 2. And now they come and tell you that you have a line that is perpendicular. Oh, sorry, but okay, this will be 90 degrees. My drawing is a little off. Alright, so this is JK, and it told you that it passes through the point 4, 1. So visually this is what you have. So therefore the gradient of JK is equal to, how do we find that? When two lines are perpendicular, we know that when we multiply the gradients we get minus 1. So we know the gradient of one of them, which is minus 3 over 2. So all you need to do is to invert it, so it becomes 2/3, and put a minus sign in front of it. So therefore we end up with 2/3. So the gradient of JK is 2/3, and we know that it passes through the point 4, 1. So therefore the equation of JK will be y equal 2/3 x plus c. And we know that when x equal 4, y is equal to 1. Right? And 1 is equal to 2 over 3 times 4 plus c. You can multiply everything by 3. So we have 3 is equal to 8 plus 3c. Let's put the 3c here. Plus 8 equal to 3. 3c is equal to 3 minus 8. So 3c is equal to minus 5, and therefore c is equal to minus 5 over 3. Alright, so the equation of the line we are looking for is y equal to is equal to 2/3 x minus 5 over 3. Make sure that's correct. Yeah, so we can write this over as 3y is equal to 2x minus 5. Right? We have another one here. They give us an equation of a straight line, and we want, is it the same question? Oh, no, it's different. Okay, so we have 3y equal to x minus 6. What is the gradient? So we need to write it over in the form y equal mx plus c. So 3y equal 2x minus 6. We divide throughout by 3. So we end up with 2/3 x minus 2. So therefore the gradient of the line m is equal to 2/3. Now in part 2, there's the equation of the line. Right, that equation is perpendicular and passes through the point 4, 7. So we have one equation that we know, which is 3y equal 2x minus 6, and they're telling us that we have a perpendicular line that passes through the point 4, 7, and they want the equation of that line. So we know m for this one is 2/3. Therefore, m for the perpendicular line will be minus 3/2. Because we know that for perpendicular lines, when you multiply the gradient, you should get minus 1. So therefore, y is equal to minus 3/2x plus c. And we know that when x equals 4, y equals 7. So therefore, 7 is equal to minus 3/2 by 4 plus c. Therefore, 7 is equal to minus 6 plus c. Therefore, c is equal to 7 plus 6. Therefore, c is equal to 13. So therefore, the equation becomes y is equal to minus 3/2x plus 13. Okay. Alright, we have an easy one here. This is June 2010. So you have a straight line passing through the point 4, 1, and they give us a gradient. So the equation will be y equal mx plus c. M is 3/5, they gave us that. 3/5 x plus c. And it passes through the point 4, 1. So when x equals 4, y equals 1. So therefore 1 is equal to 3/5 x, which is 4, plus c. And we can multiply everything by 5. So we have 5 is equal to 12 plus 5c. So therefore 5c is equal to 5 minus 12. So 5c is equal to minus 7. And therefore c is equal to minus 7/5. So therefore the equation becomes y is equal to 3/5x minus 7/5. And we can write this over as 5y equal 3x minus 7. Right? We just multiply everything by 5. Okay, we have another question here. This is January 2009. And we have a straight line passing through the point P and Q. State the coordinates of P and Q. So P is, we're just reading off the graph here. P is 0, 3, and Q is minus 2, 0. Alright, so that's part A. Then we want the gradient of the line segment. Well, basically we find m again, so m will be equal to, now we've done enough, so you should know the formula by now. It's y2 minus y1 over x2 minus x1, which is equal to, let's call this x1 y1 x2 y2. So it'll be 0 minus 3 over minus 2 minus 0, which is equal to minus 3 over minus 2, which is equal to 3/2. So that's the gradient. Then they want the equation of the line segment. So the equation will be y equal mx plus c. So it's 3/2 is the gradient. And well, I don't need to work out c because I can read this directly from the graph here. It passes through the point 0, 3. So it's 3/2 plus 3. Right? So no need to go and calculate anything. You can read it off directly from the graph. So that's part 2. In part C, they said the point minus 8t lies on the line segment. Find the value of t. So we know the equation of the line. The equation of the line is y equal to 3/2x plus 3. And all we need to do is to substitute minus 8 into it. So when x equals minus 8, y is equal to 3/2 by minus 8 plus 3. And this will give me 2 into 8 is 4. So 4 3 is 12. So it's minus 12 plus 3, which will give me minus 9. So therefore t is equal to minus 9. Alright, now they come on and tell you that a line segment AB is perpendicular to PQ and passes through 6, 2. So therefore, the gradient of AB will be equal to, right? So that's for AB we're talking about here. They are perpendicular lines. So we need to invert the gradient of PQ, which is, so it'll be 2/3, and put a minus sign in front of it. So the gradient of AB is minus 2/3. So therefore, y is equal to minus 2 over 3 x plus c, and we are told that it passes through the point 6, 2. So we just substitute into the equation. So we have 2 is equal to minus 2 over 3 by 6 plus c. So therefore 2 is equal to minus 4 plus c. Therefore c is equal to 2 plus 4. Therefore c is equal to 6. Alright, so the equation of the line AB is therefore y equal minus 2 over 3x plus 6. Okay. And we have a straightforward one here. We have, this is from the January 2007 paper. We have 2 points, P and Q. So we can label that as x1, y1, x2, y2, and we want the gradient of PQ. So gradient M equal y2 minus y1 over x2 minus x1, which is 10 minus 4 over 6 minus 2, which is 6 over 4, which is 3 over 2. Right, so that's the gradient of PQ. And the midpoint, big M, is equal to x1 plus x2 over 2, y1 plus y2 over 2, which is 2 plus 6 over 2, 4 plus 10 over 2, which is equal to 8 over 2, 14 over 2, which is 4, 7. Okay. This is January 2006. So we have an equation of a line y equal 4x plus 5. State the gradient of any line that is parallel to L. Well, this equation is already in the form y equal mx plus c, and the gradient is 4. So therefore the gradient of any line that is parallel to L will be 4. And determine the equation of the line parallel to L and passes through 2 minus 6. So therefore we can say that y is equal to 4x plus c. And we know that when x equal 2, y is equal to minus 6. So therefore minus 6 is equal to 4 by 2 plus c. Minus 6 is equal to 4 2s are 8 plus c. So therefore c is equal to minus 6 minus 8. Therefore c is equal to minus 14. So the equation of the line will be y equal 4x minus 14. Okay. And our last question, we have P, Q, and R, and I want to calculate the length PR. Okay, so the first part, length, we know is x2 minus x1 squared plus y2 minus y1 squared, and the square roots of that. Alright, so be careful what you're doing here because you have 3 coordinates. So P is this one, and R is this one, right? So you can label your x1, x2, and y1, y2. Alright, so essentially it's the difference of the x coordinate squared, so it'll be 4 minus 1 squared plus 2 minus 3 squared. Find the square root of that. So this will be 4 minus 1 is 3 squared plus 2 minus 3 is minus 1, so it's minus 1 squared which is 9 plus 1. Right, so it's a square root of 10, and we need to put units here. Right, now we want the gradient of PQ. So we know m is y2 minus y1 over x2 minus x1, and we're looking at PQ this time. So PQ is, right, so this is P and this is Q and this is P. Right, so we can say 5 minus 2 over 12 minus 4, which is 5 minus 2 is 3, and 12 minus 4 is 8. So the gradient is 3/8. And then we want the equation of the line that passes through R parallel to PQ. So we just worked out the gradient of PQ. We got 3/8, right? And we want an equation of a line that is parallel to PQ. So therefore it must have the same gradient, which is y equal to 3 over 8x plus c. And we need to find the c. But we know that the line passes through the point R, which is here, 1, 3. So therefore 3 is equal to 3 over 8 by 1 plus c. We multiply everything by 8, so we end up with 24 is equal to 3 plus 3c. So 3c is equal to 24 minus 3. Therefore 3c is equal to 21, and c is equal to 21 over 3. Therefore c is equal to 7. So the equation of the line that we want is y equal to 3 over 8x plus c, which is 7. Okay. So with coordinate geometry, you need to practice some questions, and this is a good starting point.